So we should have already learned about physical properties, and physical properties are properties of elements or matter that we can observe without actually changing that matter. So now we're going to talk about the other side of things, chemical properties. And chemical properties is essentially whether or not something is going to react with something else. So is this element going to react with another element to form something new? Or is this compound and this compound going to react? So it is important that we note that in these cases we can only observe chemical properties by observing chemical change. So we actually have to change the identity of the compounds in order to observe those chemical properties. So we can observe chemical reactions by recognizing 4 different factors that tell us that a chemical change is occurring. The first indicator of a chemical change is a production of a gas. So when we put 2 substances together, some indicators can tell us that a gas is being produced. One is the formation of bubbles. Sometimes there will be an odor. Sometimes you can actually see the color of the gas, as we did when we did the nitric acid penny demo. So the first indicator of chemical change is production of a gas. Now the second indicator is color change. So if you put 2 substances together and they form a new color, then that is an indicator that a chemical reaction has occurred. Heat or light can be released or absorbed. So heat and light are both forms of energy. So energy either being taken in or released during a chemical reaction is an indicator that that reaction is actually occurring. And then lastly is something called the formation of a precipitate. A precipitate isn't like rain like you learn in earth science. A precipitate in chemistry is when a solid forms from 2 liquids. And in a second, I'm actually going to give you an example, show you an example of this, since it's something you probably haven't seen before. So just keep in mind that both physical and chemical properties can be used to identify substances. So let's go ahead and take a look at the formation of a precipitate. So underneath the Elmo here, I have 2 liquids. I don't know if you can really see, you can kind of tell. So this is lead nitrate. You can see it's a clear liquid, and then here this is potassium iodide. They're both clear liquids. So I am going to start by adding the potassium iodide to the beaker. Right, I'm just going to dump a little bit in there so it covers the bottom and you can see it. Alright, so you can tell it's just a clear liquid. And then I'm going to add this lead nitrate, and you'll see what happens. Okay, so I just put 2 clear liquids together, and that bright yellow powder stuff in there is the precipitate. It's actually a solid that has come out of liquid. So you can kind of tell that it's in a powder form and it's not a liquid form. So that's an example of a formation of precipitate. And we'll do those later in the semester when we do some more chemical reactions. So just one more thing that I want to mention before I finish this video is about the law of conservation of mass. Let's see if I can get the PowerPoint to pull up here. Alright, so one of the most important rules in chemistry is the law of conservation of mass, or the law of conservation of matter. So it's important to recognize that when we're observing compounds or elements, either observing physical change or a chemical reaction, that mass is always conserved. So mass is neither created nor destroyed, it only changes forms. So when we put 2 things together, the mass of the reactants is always going to be equal to the mass of the products that are made by that chemical reaction.